my dear students. I congratulate to all of you on behalf of getting wonderful result in PU examination. Now this class is about NEET orientation, JE orientation towards important and frequently asking preparation method of primary amine from amide, that is Hoffman bromamide degradation. So this class is exclusively for competitive orientation to expand the learning levels. Okay, and what the reaction is, this is Hoffman bromamide degradation. Just I am recalling the previously discussed main reaction, and other aspects will be taken very soon quickly for your better understanding. Degradation means some reduction in the product. Yes. The simple reaction for your kind information is RC double bond O NH2. Yes, if this hydrogen, this N atom contains two hydrogens, this is called primary amide. Okay, is treated with bromine with an alkali. That alkali is either KOH or NaOH. Both are same or similar in working action, dissolved in either water or alcohol. Yes. The reaction mixture is heated, and this is 4 moles as per balancing purpose. Then you will get R, this CO group is expelled, and what is observed? NH2 group is resulted. It is primary amine, maybe aliphatic or aromatic, no problem at all. Other products are Br2 K combination KBr, and CO becomes K2CO3, then water molecules. This is useful towards a PU examination to get 1 mark, statement 1 mark, 2 marks. Now take the mechanism regarding JE NEET orientation. You are not insisted to practice mechanism, but observe and remember the main aspects involved in the mechanism is important. Why? Because it is not a PU oriented information, only competitive. Therefore, some key information to be grasped. Then come to this one. C double bond O NH2 is amide. Which amide? Primary amide. Why primary word is used? No substance on N atom. N atom should contain 2 hydrogen atoms. NH2 should present. And the reaction is, here KOH base is a playing role. In the place of these two, what may be given? Yes, by the combination of these two, it produces KOBr. To confuse the student towards competitive examination, or NaOBr. Information is same, even the representation is looking different. Then in the presence of base OH minus, these hydrogens are showing some acidic nature, as this hydrogen is removed by this OH group and H2O is removed from the reaction mixture. You got a compound that is R C double bond O N, already one lone pair of electrons there, H there, and what is resulted? One more bond pair is resulted as lone pair and negative charge. This negative charge is ready to dissociate a non-polar molecule. Yes, non-polar is induced by anion. So this is induced dipole ion, induced dipole attractions are there. This is shifted here and this is attracting this Br plus part. Then you will get R C double bond O as usual. N is attached with Br and this N contains hydrogen lone pair. Yes, based on this product, one of the products, the name is designed and it is bromine on N atom. It is N brom and what is the group? CONH2 type group is amide. That's why the name is resulted. Don't bother, very easy. Once again, here what is playing a role? OH minus ion is playing a role. Second acidic hydrogen is also removed as water and we got an important species, that is R C double bond O N Br, correct? Already one pair is there. One more pair of electrons from this NH bond is resulted and this nitrogen acquires negative charge. At this stage, what happened? Yes, it is ready to rearrangement. Internal rearrangement is taking place. Very simple. Br is ready to coming in this case. And you will get, so here if Br minus is expelled from the reaction mixer and the resulting one is typed like this, R as usual, C double bond O as usual, and nitrogen acquires already one pair, second pair also there, but this nitrogen contains two lone pair electrons and one pair of bonding electrons. Total 6 electrons is an electron deficient one and it is known as nitrene. This you have to concentrate. Some books RCO is also used and it is named as RCO group is called acyl group and it is known as acyl nitrene. This is happening and in a slow manner, that is decomposed rearrangement, intramolecular rearrangement, and it is a slow step. This slow step you studied previously known as rate determining step in assembly mechanism in case of haloalkenes and haloarenes. This is, and here it is a rearrangement, in which case single step. How is that one? Very simple. I would like to show. This alkyl group is migrated from carbon to an atom and one of the lone pair of electrons migrated between carbon and nitrogen to satisfy tetravalence of carbon. Then we got, yes, C double bond O as usual there, and between carbon nitrogen double bond there. On nitrogen what is migrated? Alkyl group is migrated and this is known as isocyanate. This we have to concentrate as a second intermediate. This is first intermediate. On this case some questions will be designed. What is the reactive intermediate formed during Hofmann bromamide degradation? Then your answer is isocyanate is simple answer, or if it is not available in the options, another one is an electron deficient electrophile is nitrene like carbene. Now at this stage this isocyanate, simple answer, water molecule, it is decomposed by water molecule. Suppose H2O written like this, then what is happened? Oxygen on carbon, CO2, N is attached with H2, RnH2 and CO2. I would like to expand little more steps from other books. Okay, then This is electron deficient. Carbon becomes electron deficient due to electronegativity, higher electronegativity of carbon atom. Higher electronegativity of oxygen atom than carbon atom. Therefore, the electrons are migrated like that, and OH minus ion is attacked in this way. How? To carbon. Then it is written like this: R N double bond C, and that C double bond O becomes O minus, and OH is attached. The pair of electrons on this oxygen atom start migrating between these two, carbon and oxygen, and here the pi electrons of this one is migrated and it is stabilized by resonance. Why? Because anion, negative charge, sigma bond and pi electrons. This is a negative sigma pi resonance. Negative sigma pi resonance. For the understanding purpose. Then what is resulting? Very simple. It is rearranged like this: R N H, and this becomes, this hydrogen is also migrated. At the same time, the hydrogen is migrated to nitrogen atom. It becomes NH. H plus shift or exchange. H plus exchange. Okay, then it becomes C double bond O, O minus. At this stage, what happened, dear students? At this stage, as an individual molecule, this negative charge is dispersed here and the bond is broken like this, and you got a compound, that is, here carbon dioxide is expelled. The important compound is NH with which charge? Without bonding electrons, CO2 is expelled, and these bonding electrons on nitrogen atom, it acquires negative charge, R, NH. And now it is treated with water molecule in order to get R, NH, and from this water molecule, what is resulted? Another H is resulted plus OH minus. Okay, this is the end of Hoffman bromide degradation mechanism. In this case, what you have to remember, very simple, that is acyl nitrate is intermediate. If it is not available, isocyanate, in many examinations frequently asking, and this is useful here, RNH minus. Based on this one, some examples towards examination to be concluded easily. Now, this is for competitive examination. Example 1. Methyl group CONH2. This nitrogen with a mass number, 15, nitrogen 13, nitrogen 14, nitrogen 15 with the same atomic number. These are isotopes. Isotopic nitrogen. Understood? Now, simple. Instead of writing the total one, you are expecting the product. That is Br2 KOH. As usual, aqueous. Then, what is the product? I would like to give two options for your better observation. Without hesitation, option 1, MENH2. Option 2, MENH2 with 15 mass number. Yes, which is correct, dear students? Yes, this CO group is removed, and this NH2 directly attached to methyl group. That N is nature not changed, that is isotopic nitrogen. Answer is this one. Now, in the second question, this knowledge will help you to decide the product. That is, CH3 can be written as methylamine CONH2 plus ethyl CONH2. Two different amides are taken. In one amide normal nitrogen 14, another amide it is 15, and treated with, as usual, KOH-Br2. When you see primary amide KOH-Br2, NaOH-Br2, Cl2, I2 combination, what should be flashed in your mind? That is Hoffman bromamide degradation. Okay, dear students, how do you answer? I would like to give options for a better understanding. Option 1, that is methylamine and ethylamine. Second option, methylamine 15 and ethylamine 15. Third option, methylamine normal and ethylamine 15. Fourth option, methylamine 15 and ethylamine normal. I am saying common names of these compounds. Yes, here it is intramolecular. The migration is intramolecular, very important. This is intramolecular for your better understanding. This is intramolecular, no exchange. So here this nitrogen not exchanged with this one, therefore this is removed, attached, this is removed, attached. So the correct answer in this connection is methyl group normal NH2 and ethyl group isotopic NH2. Third option is correct. Okay, so knowledge of first equation reaction helps you to decide the products in the second case. Okay, right. This is for your better observation. I still keep the mechanism for your observation. Third example to be taken, that is phenyl group with amide C double bond O NH2 treated with potassium deuteroxide dissolved in heavy water like aqueous solution. It is heavy water solution with Br2. The product is. So options are to be given. Yes, option 1 is pH NH2. Option 2 is pH ND2, which is correct. Yes, you observe the last step and the middle step. What is these middle steps? From isocyanate to this final step, what you observe? Hydrogens are coming in the product RNH2 from the solvent. Yes. What you are doing? These hydrogens are coming from solvent, not from parent amide. Parent amide has NH2 hydrogens. They are removed during the reactions with a base, and the hydrogens are coming from aqueous solution, that is from solvent. So from that knowledge, it is clearly answered as pH CO is removed, then directly attached to NH2, but these hydrogens are replaced by this deuterium, and the answer is second one. pH, C double bond O, ND2. In the place of hydrogens, deuteriums are taken, and for your understanding it is deuteroamide is now treated with the same story, KOH aqueous with Br2 as by using the same options. How do you answer? In this case, the product is pH, C double bond O is removed, and in the place of C double bond O, ND2 not coming, dear students, and N is attached with this deuterium, hydrogen, NH2. This is the answer. So this is the difference between third case and fourth case to decide the product with the help of the knowledge involved in Hoffman bromamide degradation. Yes, two more examples will be taken and close this one. Just examples are to be erased. Next example, on what basis? Yes, based on this rearrangement. This is a ring and the group is away from the observer. Instead of writing C double bond O, I just simply finish, and this is a nearer bond to the observer. Solid wedge, discontinuous wedge, solid wedge formula, and it is asymmetric carbon. Now treated with Br2 KOH. I shall give you two options. Option 1, this is cyclohexene ring with a NH2. Why? Because CO group is removed. That's why this amine which is formed has one carbon less than parent amide. That is why it is called degradation. Now, second option is cyclohexene ring and it is near to the observer, which is correct answer. Both are looking same, but here three-dimensional arrangement is taken and the group S. Here the migration of alkyl group chiral carbon retains its configuration. With the retention of configuration. What is the point? Yes. With the retaining of configuration. In which configuration? CONH2 group is attached to this chiral carbon away from the observer. Here also this cyclohexenyl ring is also away from the NH2 group. Therefore, this is the answer. So this step helps, or based on this step, the question is designed. And based on this step, one question is to be taken. Before that, one simple example to be taken, that is NH2 C double bond O. NH2 is urea. Urea is subjected to Hoffman bromamide degradation Br2 KOH. What is happened? Yes, this NH2 considered as alkyl group, and this is amide group, primary amide, and what is observed? This NH2 attached to this one and this group is removed, and the answer is NH2. NH2. This is hydrazine. Okay. Your preparation is very much lengthy in this case. The last example to conclude the program. Here the unexpected product is to be observed. The last example, CH3, CCH3, Br, and CONH2 is the group, primary amide group, is now treated with as usual Br2, KOH. The products are CH3 twice CBr-NH2, second one CH3 CO CH3, third one CH3 taken twice CH NH2, fourth option none. Better to utilize your leisure time and interact with these videos. Any questions, better to comment. One student commented in the previous case regarding Gabriel thalamide synthesis, that is a nucleophilic substitution between N-bromo thalamide to N-alkyl thalamide. In that case, a nucleophilic substitution is explained. You just go through that one. As if this group is migrated, what is the intermediate? This is the intermediate. Then CH3, CBr, CH3, NH minus. This is to be observed by the student. Generally, this answer will be selected by many students, but here amazing thing is happening. This is now. Yes, here it is Br is a good leaving group and it leaves, and here it is dispersed. Then you will get NH double bond C with two methyl groups. This is now with KOH excess with Br2. Then Br2 not playing a role. Here hydrolyzed. This group is hydrolyzed. And this group is called C double bond NH group is called imine, and you got the product simply CH3 C CH3. What is the result here, dear students? Here water molecule like this, H2O cleave like this, and you got, yes, this is the product which is called acetone. That is the end of the program. Have a nice interaction. Thank you very much.